I don't speak any Russian. I didn't really understand the introduction. I hope they were very kind words. And I would like some Russian speakers like, yes, it was kind words. Lovely. So, my name is Tobias. I have a talk titled Symfony without the framework bundle. And I'm going to do this talk because we care about performance. And going bare will get you a better understanding about what the application is doing. And I'm also doing this talk because I believe it's fun. So first, show of hands, how many of you are using a framework? How many of you are using Symfony as a framework? Excellent. How many of you are using a different framework? Also excellent. Last question. How many of you know exactly what Symfony is doing for you? No, okay. How many of you somewhat know? Yeah, okay, excellent. Then that's lovely because you're gonna like this talk. This is the perfect talk for you then. Shortly about me, I work at a company called Happier. I do plenty of Symfony stuff. I also managing PHP meetups in Stockholm, and I do plenty of open source. I started my open source career back in 2015. PSR 6 came out, and we were at the conference, and me and my friends were like, "Hey, why don't we build implementations for PSR 6?" That's the caching PSR, the first caching PSR. So we built that, and it was fun. I enjoyed it. At the same time, there was a group of people doing HTTP plug, which was an abstraction over HTTP clients. So we did that, and when you're doing HTTP clients, you do a lot of API clients and a lot of mail clients. And I wrote like, "Oh, this is how you should do a client thing." And currently, I'm maintaining both Guzzle and Bus. I've written my own PSR implementation. I wrote the PSR 18, like the PSR for HTTP clients, and a bunch of other things. The most interesting library here is the NSA one. NSA totally violates all class privacy. So you can easily access private properties or private methods using NSA. You could say it's good for testing, but it's just, again, just for fun. Nevertheless, let's get started. This is something I hear time to time. I guess you've also seen someone tweeting, "Oh, don't use frameworks, frameworks are slow." And I want to investigate during this talk. I want to investigate if this is true or not. Are you with me on this premise? Excellent. Also, I'm not sure, I would really like you to just nod along a little bit, just to show that I'm doing a good job, or maybe you could shake your head if I'm talking too slowly or too quick. Is that okay? So, frameworks are slow. Let's break this down. It's 3 parts, and the middle part is quite simple. But what is slow? I imagine like slow means poor performance, right? But frameworks, what is a framework? I mean, I'm honestly asking this now. I mean, you all raised your hand when I'm asking you, are you using a framework? So what's a framework? Set of components, a way to program things, or more specifically, what is Symfony? So for the past 3 years, I've been throwing out these questions both in public and in private conversations, and for every person I ask, I get a different answer. So let's investigate. I'll bring you back some history. Back in the days, if you want to create a new Symfony 1 fresh and shiny project, you did your SVN checkout. And this was, you get a big fat Symfony file, everything was in it. It was vendors, everything was in that file. And if something was in that file, in that folder, there was a Symfony thing. So if it was a command in that folder, it was a Symfony command. And if you have this folder in your application, you had a Symfony application. So it was a really clear line from what is Symfony, what isn't Symfony. But if we play forward 5 years, you have Symfony 2.8. You used Composer. You did not include any vendors. You still had a big folder that's called the Symfony folder. Symfony 3 was pretty much the same thing. A lot of legacy stuff was removed, but still have this big folder. However, in Symfony 4 and also in Symfony 5, there's a much less code. There's basically nothing. There's no Symfony folder anymore, and also it's barely any dependencies in Symfony 4. Like if you're checking the default composer JSON, it looks like this. And this is just some PHP stuff, some PHP extensions, and then you have the composer plugin and then 3 other dependencies. It's not much code here. And to answer your question, to answer your answer? You said that Symfony is a set of components, and I'm like, which components? Like, what is Symfony? Like, sure, we can argue that if you use HP kernel and HP foundation, that's Symfony. That if you have an app that's using those 2 dependencies, that's a Symfony application. But with that same logic, if you include a PSR7 library, is that a Send application? Sure. Sure, that's a valid point. Like the skeleton you're starting from, but if you have a composer JSON file looking like that and some more, I wouldn't argue that's not Symfony. It's not Symfony enough. Not for me at least. So these 2 libraries, sure, they're important, but they don't define Symfony. So if we got no Symfony folder, if we got no single dependency or no group of dependencies that say this is a Symfony app, again, what is Symfony? So I'm gonna take a different approach now. I'm gonna try to visualize stuff. So again, Symfony versions, and back in the days, you need to have all your controllers in a folder called controllers. And you need to have all your commands in a folder called commands. And there was a lot of weird paths and configs things you need to figure out. And sometimes when you want to include something, you have to use the @ sign. Sometimes you didn't. So it was a lot of weird stuff going on. So I would say, but back in Symfony 1, there was a lot of magic. And magic has slightly decreased, while the user responsibility, like what you are doing with your application, has increased. So the line between what's Symfony and what's not has been more and more diffuse. So when this fancy animation is done, Symfony 4, yes. Or, yes. So, in my mind, what I've concluded, Symfony is a community. Like we are Symfony. We all are, since we're here in this conference. Everybody that writes issues on GitHub, everybody that writes answers or comments on Stack Overflow, everybody that is tweeting, everybody that's on the Slack, we are Symfony. And Symfony for me is also an ecosystem of bundles, libraries, gists, Docker images, and everything that we make is part of Symfony. Everything we publish, like blog posts, and code is not the primary thing. Like blog posts and meetups and tweets are helping Symfony, helping the community. So if you want to contribute to Symfony, the easiest thing to do is start small. Like tweet, say, hey, thank you for the Symfony camp. I really enjoyed this conference. And I can pause a moment now so you can tweet. But jokes aside, this is actually part of contributing to Symfony, helping the Symfony community to be a better community. But so, if Symfony is a community ecosystem and whatever we make, a framework is just the code on packages, like the code we made, right? So back to this, frameworks is just our code. And if frameworks are just our code or a library that our code depends on, is that really slow? Like if I was telling you, hey, you write slow code, you will be quite offended, right? You were like, no, I write the best code ever. So let's talk about performance. Let's talk about slow code. I have 3 important rules about performance. These rules are going to say to you, they are always true, no matter what. Rule number 1, buy a better server. this is by far the most cheapest way to get your site better performance. Because hardware is so much more cheaper than software. And we are the software in this case. Okay, rule number 2, use Varnish. Most people do this, it's awesome. And you can imagine, if you let Varnish handle 95% of your traffic, it's gotta be super quick. And there's a lot of talks about this topic. I'm not gonna mention it at all. There's a lot of talks saying how we handle 1 million requests a second, or how we do this amount of traffic. And what they're gonna talk about is basically Varnish. It's a lot of talks, articles, and videos about it. I'm not going to mention Varnish anymore. But rule number 2, cache, that's the thing. Rule number 3, though, this is what I'm passionate about. This is what I want to talk about. Is run less code. This is like the only way how you actually speed up execution of your application. You're running less code. Do you recognize this? I wouldn't say like, do you know this, because nobody knows this. If you say you know this, you're lying. This is basically PHP echo hello world. And whenever you execute PHP, it gets compiled, a lot of optimizations get compiled down to machine code. Each of these line is one tick in your CPU, right? And on your computer, you probably have a 3 gigahertz CPU, and that means that your computer can run 3 million of these lines every second. So the more of these lines you have, the slower your application is going to be. And I state this with more code, more ticks, and that's what makes things slower. So if you heard like, oh, you should use this algorithm because it's really quick, it means that this algorithm using less code, that's why it's quicker. Or it's running less code, that's why it's quicker. So as a scientist, as I am, or pretend to be, I did some research. This is different Symfony versions, and I was running the hello world in these applications. That's the only thing I did. And this is the total amount of code, this is the lines executed to write hello world, and then I have the number of function calls, memory, and the time it took. And it's a nice slide, it's a lot of numbers. What I want to point out is the less lines executing, the less time it takes. That's like, it's kind of not true, but you see the general pattern. And for the record, I'm not very, Symfony 1.4, I'm running that in development mode, that's why it's way worse than it actually is. So, this is hello world, and you can argue 31 milliseconds to run hello world is awful. But our application is not doing hello world, right? If we were doing hello world, we should write something like this. Like this, it's the fastest application for just doing hello world thing. The more similar your application is to this, the quicker it will be, because this is less code. So, since we're not doing hello world, we need to figure out what are we doing? And it's really, really hard to give you a generic answer for your specific problem. Like if you would have a generic, super slim micro framework, that's basically the Symfony skeleton. That's as small as it can be, but still super generic and flexible. But since we know our applications, we know our problem, we could be smarter or more slim. Like I have one application that's basically a URL shortener, and the full application looks like this. It basically reads some globals and do some pattern matching and then do a redirect down here. And it's not a good or fancy application. I wrote this in less than an hour and then was deployed and stuff. What I want to stress is, we all know in this room, if I were about to use a framework for this, it would be overkill, right? There's time to you too. Yeah, it would be overkill. And you could even argue why I'm using PHP for this. Why don't I use Nginx to do this kind of thing? And the reason is simple, because I don't know Nginx well enough. I know PHP. So whenever we're starting a new applications, we're going to figure out where on this scale this application is going to be. Is it going to be as simple as my redirect applications, or is it going to be way, way over here, like a big fat applications using forms and stuff? Like, we gotta figure out where on this scale. So, in order to do this, I like to play a game whenever I start an application. It's called Do You Need This? So I basically ask myself a bunch of questions. Do I need security? Like, if we're on a private network, do we really need security? Probably not. Do we need forms if you're using a microservice? If you only get a few routes, do we need a router? Like, Symfony 4 has the fastest router ever written in PHP, but if you only have 2 routes, an if statement is obviously faster. Do you need a kernel? Like, if you only have a small code base, do you need a kernel? Or do you need dependency injection if you only have 10 classes? Also, do you need classes? And do we need HTTP if we only using CLI? Or maybe if you do need HTTP, do we need HTTP Foundation? I mean, I hope all of us know that it's basically impossible to get the user's IP address from the globals. It's easily spoofed and you cannot rely on it. It's super tricky. HTTP Foundation helps us with this. But our application is probably not going to bother about the user's IP, right? So if we don't need HTTP Foundation, we should not use it. Maybe we're happy with just using request URI. And also, do we need the messenger component? I love the messenger component. It's great because it's easy to read from queues. I have an application, it's a recommendation engine. It's basically just pulling things from a queue and storing it to a graph database. And using the messaging component there is for me, it's great. And speaking about storing things to a database, do you need Doctrine? Or are you happy with just a PDO? Like, all of these things are helpful to consider if you want to build small and really fast applications. I'm not saying Doctrine is bad, I'm just saying maybe it's not the best for performance. I've been using Doctrine for forever, and then someone asked me, hey, can you just write a MySQL connect and just use pure PHP functions? And I couldn't. I have to go to PHP introduction courses to figure out how I connect to database, because I'm so comfortable with Doctrine. So it's like, if I didn't use Doctrine, the development pace would go down, but maybe the application speed would go up. So it's always a balance. And what I want you to do is consider the decisions you're making. Like, you consider, is it important to me that I do this properly with no bugs and develop quickly, or is it more important the application has a low response time? And it's not, one answer is not correct. It depends on your specific case. So, I've got to tell you, are you fine with this, me telling you this? Does that make sense? Okay, excellent. So I've got to try to tell you how I do things, how I build small microservices, because it's hard to give a generic answer. So I guess if I'm sharing some of my thoughts, you say, I like this, I hate that, and then you do your own thing. Okay? So I'm not telling you the truth, I'm telling you my truth. And please. So, I already mentioned the messenger component, which I like. I'm using it even when I'm not using asynchronous stuff. This messenger component is a way for me to develop my applications, use my architecture. And I also do like the workflow component. The workflow component, I will talk a bit more this afternoon, but it's great for me to help me with organizing the application's state. So I have an inbox service that basically sends emails and shows user the inbox. And I have a state machine basically like this. So I have every email could be in a before sent, error, delivered state, and then I define how to move between them. This helps me to make sure I will never send an email twice by mistake. I know exactly which state the email has at all times. And the messaging component is great because it's helping me with this. So I'll talk more about it tonight, but the messaging components, the workflow components is something I use a lot. I promise not to talk about caching, but Symfony has a new cache interface in their component. It's about a year old. Have you seen it? Excellent. And I heard your excitement because the cache interface has built-in stampede protection. The interface basically looks like this. It's also a delete function, but it's basically like this. And the cool thing about this is the stampede protection, which is a fancy word, and what it really means is if, oh no, this is how we use it first. So basically, if the foobar does not exist, if that doesn't exist in cache, we call the function and we starting to do the work. Here we're computing pi and we store this result for 1 hour. So if you have this traffic coming into your site, the first request at T0, the cache is cold. So we start computing pi, it takes 3-4 seconds, and then we store the value in cache and then we serve to the user. Then we have a lot of requests after that, right? And after 1 hour, the cache has expired, so the cache is cold again. This is where stampede protection is helpful. Or if you don't use stampede, you'll have 100 requests coming in, and what do? You start calculating pi 100 times, which is obviously bad. I mean, you can see this, if you look at your CPU performance, you see it's flat, and then you have a spike. And it's flat, and 1 hour later, you have another spike. So with stampede protection, you prematurely invalidates one call to the cache. Way before the hour has expired, so this user in the middle, that user has to wait for the pi to be computed, and you don't have the spikes anymore. And this is why I do like the new cache interface. Did all of you know about this? Okay, that's amazing. I mean, that's amazing. So I use the cache component and this cache interface because it's simple to use, it has this built in, and those are basically the 3 components I always use. And if I'm building something super small, I'm using the middleware pattern. The middleware pattern is basically the same thing as PSR 15, if you're into Fig. Okay. Excellent. This is my index.php file, and I'm using the middleware pattern here. What I'm doing here, I'm creating a request and a response, and then I'm creating 2 middlewares. It's just an anonymous function. The first one, make sure you have a GET request, and the second one adds some content to it. And then what I do, I have my runner, which runs the middleware in order. I run the first middleware, then the second middleware, and out come a response, and then I echo response. This is my full framework. And the result of this code, it's quite boring. It's just foobar. The magic is in the runner. Do you understand what I'm doing here? Or the general idea of what I'm doing here? I define a few middlewares and then I run them. And in this runner, it's just an invocable which I loop through the middlewares. First take the first middleware, then the next one, the next one, the next one, and when we don't have any middlewares anymore, we just return the response. That's it. And if you think this looks weird with the anonymous function stuff, you could just use an interface and then just do a normal class and that works as an invocable. Here I implement a router using this middleware pattern. And as you can see, this router is basically taking the URL in a switch case. And if I didn't find anything, just do a 404 response. Are you comfortable with this? Excellent. So I can write the application like this now. So this is actually a nice little framework I created. Or you just saw all the code. And the cool thing about this is that this is only your code. Like I've written all these 10 lines, and I've written all my middlewares as well, and I'm in full control of the code that is in this framework. Sure, in the cache middleware, I decided to use Symfony cache, but I've decided to include the Symfony cache. So I'm saying, I'm in full control of all the code, all the dependencies, and what I include or not include. I've written, the first application I wrote like this was a geocoder, which basically did some caching, did some New Relic, and then have security, and then the router called the controller to actually fetch the geocoding data. So, sometimes I'm stopping here when I'm writing this application. Sometimes I feel like, no, I need something more. I need some YAML config maybe. Or I mean, here I'm having a cache, and you know it's impossible to develop develop an application to see changes if you have a cache in front of it. So you basically want to have a null cache or something here first. So you want to have different, if you're in dev, you don't cache, if you're in production you do cache. So I want to introduce different environments. And maybe I want to use dependency injection as well. So I want to introduce a custom kernel to this because the complexity, I want to grow it a little bit. And I decided to call my kernel class kernel, and I decided to pass the environment as a constructor argument. And then I have my middleware declaration like this. You see that I'm using a container to fetch the middlewares now. And you all recognize the handle function. The only thing new in the handle function is the boot function, and the boot function looks something like this. The idea, you don't have to read all of this. The idea is, if you have a cached container, load that file from cache. If you don't, create a new container builder, add some parameters to it, say that we want to load the services, and here's how I include the different environments, like load the services underscore environment. And then I compile it and I store it to cache, or store the file. So next time I run this, I don't have to build the container again. And with this custom kernel, it allows me to have a configuration like this. And you all recognize this. This is normal Symfony YAML configuration. I can even use auto wiring, but I cannot use auto configure. If I want to have auto configure, I need to add some more bootstrap code. Basically this, I'm saying, if you ever see a class implementing the event subscriber interface, add this tag to the service. Or if you find a class as a subclass of the command, add the console command service. And if I want more and more auto-configure feature, I add more and more boilerplate, just like this. But at some point, we all feel like, oh, this is way too much boilerplate. This is getting way too complicated. Honestly now, I wrote this a while ago, and currently I don't know what the bottom two lines does. I'm not 100% sure what it does. Anyhow, but you may feel the same thing, like it's too much boilerplate, I don't understand it anymore. And if you are at that point, it's totally fine just to use the framework bundle. Because this is exactly what a framework bundle do for you. In the framework, like if you're looking at your Symfony project, you probably have the kernel class, Symfony 4, and it looks something like this. It's done the same thing as our custom kernel. We define where the services files are, and we define some parameters where the cache and log folder is. And I don't know if you noticed this, like the HTTP kernel up there, it's basically just fire off all the events when you're handling the request. And the framework bundle helps you to register all the weird compiler passes and make sure auto-configure is working. And it also allows you to, this section allows you to extend the framework. And the microkernel trait is basically just helping you to register, it's helping you to write the kernel this simple. The microkernel was introduced a few years ago, and Fabien did not like it. He did not like this trait. The reason, I think it was Ryan Weaver who created the pull request to include the microkernel trait, and Fabien yeah, I like it, but not the name. It's nothing micro about it, it's just the normal kernel. So what this does is basically helps you load things. It's not even fun to go through. It just helps you load things, it helps you have a clean interface. So I'm saying the normal Symfony kernel does exactly the same thing as our custom kernel. So we started with the middleware, and then we added our custom kernel as complexity grew, and when the complexity grew even more, we just used this normal Symfony kernel. And this is a way for naked or bare applications to grow over time, and this is also a way to deal with legacy code. Like, going bare is actually a good strategy for handling legacy code. So it's basically two ways of doing this. You could replace routes one by one, or you can replace components one by one. So let's start with the first one. This means that whenever your new frameworks returns 404, whenever a feature is missing, we go back to the legacy application. Make sense? In code, you probably know this. Sorry, in code it could look like this. Like I run my runner, and if I didn't get any good response, then I just call my legacy framework. I could do something differently now. I could be, maybe I want to share a session between them and how to handle user stuff. So I do need to add some more logic. I could add a Symfony controller action. Like I run all my routes, and if I did, instead of showing 404, I run this big fat controller. And what I'm basically doing here are finding correct file to include, and then I'm doing some witchery with sessions and stuff. But the interesting thing is this part, where I do a stream response, then I include my legacy framework, and then I just catch everything and set the correct response type. This is another way to include the legacy framework. It's ugly, but that's the nature of the legacy code, I guess. You could go the other way as well, to replace component by component. And the recipe is pretty much like this. You should focus, you have your legacy application, focus on creating controllers that returns or echo out the response. Then you have your index PHP as a front-end controller, and then you can add middlewares or components as you need it. And when you feel comfortable, you add a kernel, and then you have the migration path and actually Symfony framework. So this is the way to being sneaky, how to convert your legacy application to a Symfony application. So you don't need to do a complete rewrite. Yeah, and we also have to add a kernel and add services and stuff. I've been talking for more than half an hour now, and I've been mentioning a few different topics, like from moving small applications to big applications and handle legacy code and a little bit more performance. How do we feel at this time? Are we okay? Are you confused? No, good. We have been talking about what performance is, and how to run less code, but we haven't really been talking much how to improve performance, except for removing code. So let's talk more about performance. The 3 rules, as you saw before, if you write those in a more generic way, it's this. And again, this is true always, no matter what language you're doing or whatever. And there's a reason why we have this in order. This is because they go from cheap to expensive, and hardware is way more cheaper than software and people. Also, I gotta warn you now, unless you're doing something really extreme, there is no need to go down to number 3. The only time you go down to number 3 is because it's fun. It's because we like it. It's because we want the challenge. So, how to make your application more performant? The first thing you need to do is profile your application. You need to figure out where, you could guess where it's slow, but you need to know where it's slow. That's why you need to profile your application. I have an example application here. I'm using the Blackfire profiler. There's like 4 big profiler. You got one HFprof Facebook thing that's super complicated and it's hard to understand and use. You have Xdebug, which is weird. You have Tideways, and it's Blackfire. For me, Blackfire is simple, the most simple one, and goes well with Symfony. This is a profile. You see my function calls, and you see the time it took and how many times to call the functions. Can you tell me where this application is slow? I gotta pause for drinking, so we have some time. There was some whisper in the front. If you didn't hear, I can give you a hint. No, shh. Here's a hint. It's basically loading files. We spend so much time loading files, as you said in the front. So Composer is great with auto-loading. Composer in PHP 7 has done everything massively more efficient, but it still takes loads of time, pun intended, to load classes. It's still not excellent. So to demonstrate how bad this really is, I'll introduce you to an analogy. This analogy is created by Andrew Carter, and this is the best 2 slides you've ever seen. So the game is, imagine PHP as a restaurant. That means that the client is the customer, the server is the restaurant, the request is the order, and the response is obviously the food, the order food, and the application is the chef who creates the food, who creates the response, and the daemon is the waitress who facilitates all of this. Are you happy with these rules? So if the HTTP pipeline was a restaurant, the customer enters the restaurant, the waitress takes the order, waitress creates a chef, then chef makes food, waitress gives food, and then the waitress brutally murders the chef. If you were a management consultant and you enter this restaurant and could give the one suggestion how to be more efficient, maybe don't kill the chef all the time. Right? It's insane. So why are we doing this in PHP? Why do we constantly kill the application? So this is the same thing but more tech related. So the browser talks HTTP to Nginx. Nginx talks with FastCGI to PHP FPM. PHP FPM has a pool of PHP processes, and whenever a request comes in, you create a chef, you spin up the application, it creates the food, it's delivered the response, and then you kill it. A new request, and then you kill it. This is what we do all the time. And you probably have more requests and this happens all the time. And it makes sense because if Nginx talks to PHP directly, the creating and storing PHP processes are way more expensive. So PHP FPM makes sense. However, we could keep application loaded all the time by changing this slightly. We could let Nginx talk with FastCGI to a PHP process. The PHP process is always alive. You probably have to kill them off time to time to don't have too much memory leaks, but this keeps applications running all the time. And Symfony 4 is way better to be running all the time, but you still may have some issues. Kill them off time to time. And how to achieve this is actually pretty simple, there are many libraries that helps you to achieve this. PHP PM is one of them. I like FastCGI daemon, and you basically wrap your application in a custom kernel. So my application is this one. I used to write Hello World, and I have a custom kernel that's a PHP process always alive, and when a request comes in, we run this code time to time. I can do the same thing with my my Middleware framework. I'm just wrapping this all in the custom kernel. And this is a simple trick to keep the chef alive. If I want to do a full Symfony framework, you can easily do it with another custom kernel. And whenever a request comes in, we boot this Symfony kernel, which means that it resets all the resettable services, and then you handle the request as normal, then you can terminate the kernel. So this actually keeps everything loaded. Of course, PHP is not built for all this witchery. You have to make sure the application doesn't leak any memory. If you own the application, like if you wrote all of it and included everything, like if you have full control, if you know the framework you're building, then you can easily know and detect memory leaks. But if you're using a full stack Symfony framework, you probably have doctrine or monologue. And those are two usual suspects for leaking memory. Like, you know, monologue has this fingers crossed strategy. Do you know of it? Fingers crossed is great. It basically gathers all the logs, and whenever an error happens, it writes them. If no error happens, it doesn't write anything. So you have the full log, but you don't flood your log files. You only log when an error happens. If you keep your live running for a while and no error happens, it gathers all the logs forever, and that's a memory leak. So you need to be aware of this and just clear the buffer with every request. Same thing with doctrine. In doctrine, there is a class called unit of work. And unit of work stores all your entities for performance reasons. So whenever you say, give me user 32, it stores that in memory. Next time you ask for user 32, you don't have to check the database again. It's already stored in memory. So if you're keeping doctrine alive between multiple requests, that's everything you get from the database, it's just gathered, and you never clear that cache as memory leak. Also, you got stale data because the database might have changed. So if you do this, if you don't kill the chef, you have to be aware of other dangerous or stupid things like memory leaks. You could also, either you fix the memory leaks or you do something like this, like, oh, only run for 56 requests and then kill yourself, and then kill the chef. Or you can only run for 2 minutes and then, or you say if you use more than this amount of memory, then you kill the chef. So I'm ending my end of my talk now. I want to say frameworks are not slow. It's you as a developer that are responsible for the code you write and the code you add to your application. And if you add a lot of things, you will have a slow application. And if you're following all the things I mentioned today, you can easily write an application that's less than 10 milliseconds. In fact, you can easily go lower than that. It's no reason, like it's never needed, it's just for fun, right? But you can easily go with less than 5 milliseconds. And I've been doing this talk a few times before, and they're like, oh, Tobias, but have you tested this in production? Oh, Tobias, does it really, really work? Yeah, it works excellent. This is an application that just, the application I told you about before. It reads from a queue and writes to a database. And you see the response time is quite good. No, it's very close to it, as it should be, obviously. It reads from a queue and writes to a database. And I want to end this with remember that we are Symfony. Thank you.
Thank you, Tobias. Ребята, у кого-то есть вопросы? Есть у кого-то вопросы по докладу?
Do you have any questions?
Any questions?
Thank you for your speech. I have a question. What kind of ORM you use in this last example?
What kind of ORM did I use in this example? But I had this thing. I was writing to a graph database, so I only used the graph database client. The graph database is Neo4j, and it's basically communicating over HTTP. It's not HTTP, it's a binary protocol. So I didn't use any ORM, I didn't use any PDOs. I just used the Neo4j client.
Okay, thank you.
Thank you.
Еще вопросы?
Oh, there's one question at the back and then one question at the front.
Thank you for your speech. I caught the idea that framework is Symfony. Symfony is us, or in us. And the question is how to improve us as a framework, as a Symfony, as a community.
How to improve us as a framework, as a Symfony, as a community. I mean, the only way to improve is to contribute. And there is so many ways to contribute. I mean, either you do a code contribution, or you help someone on Stack Overflow, or you create a conference like this, or you just blog about Symfony. Like, what did you do last week? I bet you did something cool last week. Just write a short blog post about it, or tweet about it. Just say tweet about this conference, or tweet about a weird thing you found in Symfony, or whatever. Just be vocal about Symfony. That's how we contribute. That's how we make it more awesome. Thank you.
Thank you for your talk. Just a question. This fastest.js component, does it have some sort of balancing, load balancing on the PHP?
Oh.
Talking about PHP FPM, we have settings like max processes.
You're talking about this, about some load balancing.
Yeah.
So what you can do here, you can actually use Nginx to set up a group of these things, and you can ask Nginx to balance the load between these processes. So Nginx helps you with that.
Okay, thanks.
Thank you. I think that was the last questions. I will be around all day and also do a talk this afternoon. Like if you want to have more questions, I'll be here for the next 5 or 10 minutes, and then I'll be somewhere in the premises. So feel free to ask me the questions later. Thank you very much.